It's Tuesday, it's 1 o'clock, it's a new year. Happy New Year, everybody. And happy 2022. And we are back in full force here with an HDF clinic. And as always, we have our routine. It's here first and foremost to answer your questions. And in the absence of those, we have some material prepared for you, and that's what we will be doing today. So I'm going to pause here and ask for those who joined us. Thank you. Are there any questions right out of the gate? Otherwise, I'll just take us a few steps forward, and then we'll pause and see if there are any questions. Any questions? No? Okay, then I'll get going here.
Hey, Gerd, we can't hear you.
Announcements, there weren't any. I checked the forum. Happy New Year again to everybody. And there was one new post, one new thread on the forum where a user was asking about sort of file corruption, although that wasn't exactly the question. That's just how he framed it. He said he is concerned about maybe having corrupted his file, but then in his description, he was a little vague about, I think he said, I can't open this file in HDF view. However, with the command line tools, I can still look at it and so forth. So whether this is a case of corruption is another story. All I would say for now is that if what's meant here is really corruption in the sense of corrupt in the sense of it does not conform to the file format specification. Unfortunately, I mean, there is a tool called H5 debug where you can sort of dig into what's readable and interpretable about this file in terms of the HDF5 format specification. But unfortunately, there is no general purpose tool. Some of you who might be administering file systems, for example, there is a standard when your system there's a power outage or something crashes, and then sometimes you have to do a file system check, although some file systems nowadays, they do that automatically before they get mounted. And such a tool like FS check, there is no H5 FS check at this point. Yet, I would say yet, I think if you read the file format specification, even the earliest version, you see constant mentioning of, oh, we put this metadata piece in there to, in the future, make it easier for repair tools to do something useful. But unfortunately, it's stayed at that level of lip service. There has not been a tool. And there are a variety of reasons. It's not that we don't, or our users do not attribute any kind of importance to that. But then it's a matter of priorities. It's a matter of funding. There are many different considerations that go into that. But there is no such general purpose tool at the moment. However, I would like to use this to point out that if you ask, well, what are sort of typical reasons that lead to what might manifest itself as file corruption, it's frequently the case, and in a way, again, I'm not trying to deflect this here, but when you write code, that code should meet certain standards. And in the case of HDF5, but also in the case of other software, I think part of that includes many of these API functions, if not all, have some kind of return code. And you as a developer, as a programmer, it's your responsibility to check those error codes. And if you don't do that, you might just get away with it, and that's okay. Again, nobody's going to send the police. But if you are maintaining that code for a group, an environment, a project where there are some expectations with regard to the robustness and reliability and so forth, and you don't do that, I think you are doing everybody a disservice. And you should definitely start with re-examining your code and checking, am I really rigorously checking the return codes? And not just that, there will be errors sometimes for whatever reason. Then do I do proper handling of these errors if there is something to handle? In particular, do you properly free resources that might have been allocated in the run-up to that fault or to the erroneous behavior, and then see what you can do to recover from that? And what I did here is just for some context, copy a piece of code that does that kind of error handling. First of all, checking the status, and then sort of taking corrective measures, also in the sense that if you have acquired certain resources up to a point, then an error occurs. You really want to make sure that the resources that you have acquired up to this point, if necessary, also get released properly. And so here's just an example, and I'm not telling anything new here. This is what this looks and see like. In other languages, there are exception handling mechanisms and so forth. So this all looks a little different. And yeah, I would admit in C that looks pretty tedious and awkward. But nevertheless, this is code that will, in the case of an error, also give you much more meaningful information about what might have caused this error, or where to look for, where to begin sort of to debug the problem, should it repeat. And also, as far as repeatability goes, with errors, it's one thing to have an error and then a kind of sort of be able to actually reproduce that erroneous behavior. And again, this type of error checking and error handling goes a long way toward reproducibility, not so much in the scientific.
Hey,
Are there
Gerd.
any? Yeah.
I'm sorry, we lost sound again for just a minute there.
Okay. So I was just saying that. So you must have probably heard it up to the point when I was talking about to help yourself and others to also make errors reproducible. That's what you want. Not all errors are reproducible. Not all errors are reproducible, despite you doing a stellar job of sort of return status checking and error handling and so forth. Sometimes there are failures that are just the result of a combination of factors that you couldn't anticipate or nobody really anticipated. But most errors, I would say 80% plus of all errors, are really you can reproduce them if you do proper checking of status codes and things like that, and resource handling. And no, I'm not going to stand here and tell you that if you do all that, no file corruption is possible or will occur or might occur and whatnot. But it goes a long way to managing or being able to deal with exceptional or situations in which there's an error in your code or somewhere. And so I think it definitely pays off. And yes, it doesn't have to be C where it looks pretty awkward, but then in Python or in C++, you have exception handling, and this is all a lot more elegant. It's more pedestrian here in C, but still needs to be done. If you have a choice of language, of course, the more convenient error handling facilities you have, if you then use them, is good for you. But then, if you don't have a choice, still make the most of it, and do this kind of error handling and error checking to begin with. Okay, I'm going to pause and ask, are there any questions at this point? No? Okay, then I'll just press on. This is something that I prepared for last time that we didn't get to. And sort of this was my little hobby project for the holidays. I forgot, we've spoken in the past about one of the environments to work with HDF5 called HDFql. And it's a command line interface. So if you've worked with something like the QL gives it away, if you have worked with any kind of database like system, like SQL, MySQL that is, or one of the commercial relational databases, or SQLite, they all have at least some type of command line interface where you can either drop into a shell and then interactively type queries and then see the results to these queries and so forth. And HDFql has the same. HDFql also has language bindings for probably, I don't get the complete list right, but definitely for Python, for .NET, for C, C++, for Fortran, Java, and there might be a few others. What you of course would like, or what I would like, is something that looks more like one of the nice graphical user interfaces, be it just a Jupyter notebook or something more elaborate like the SQL. In the case of Microsoft, for example, there's SQL Server Studio, and there are all kinds of variations. I'm sure there's a plugin for Visual Studio Code to interact with relational databases or even non-relational databases. Now, what's remarkable about HDFql, and again, I would refer back to one of the earlier sessions where we took a look at it in a little more detail, is what I would call the lazy boy of HDF5 interfaces. And for those of you not in the United States, Lazy Boy is sort of a company, a furniture company that specializes in sort of making, sort of armchair, couch type amenities with conveniences like cup holders built in, and sort of sometimes you see in shows, they have this little crank on the side that you can pull to recline, put this whole thing into reclining position. Sometimes you have like a little control pad with buttons where you can sort of adjust the posture to your liking. And so this is what Lazy Boy is. And to me, HDFql is a little bit this Lazy Boy of HDF5 interfaces, in the sense that it gives you that conveniences, that convenience that we like when we deal with declarative rather than imperative interfaces, which means we really say, in a way, we declare what we want rather than telling some kind of environment, do this and do that. And so you have to plot the course, how to get from A to B. Whereas with a declarative framework with SQL, you just say, I want to get from A to B, make it happen. And so here's an example of what such an HDFql query looks like, is to create, and if it then existed already, truncate, if necessary, a new HDF5 file. In HDFql, you would just say create truncate and use file, and then give the file name, my_file.h5, for example. And so if I omitted, for example, that truncate end, if the file exists, HDFql is actually going to return an error and say, hey, this file exists already. And if it doesn't exist already, it will just create it. And I can work with an HDF5 file called my_file.h5 from here. And then let's say standard tasks like creating data sets or then reading from a data sets can be accomplished as easily. So for example, let's say I want to create a data set not in the root group, but I want that data set actually created at this path, my_group/my data set. So this would actually amount to creating a group, linking that group as my_group, and then inside of that group, create another link and create a data set linked as my data set. And then I say something about I want it to be a double. I want the element type to be double, and I want the initial size of this data set to be 3. And then I can sort of just annotate this even further. I can say, oh, by the way, I would like also to apply compression with this compression level, gzip compression or zlib compression in this case. And I also have an initial value for this data set. So since the initial size of that data set is 3, it's one-dimensional, I want the initial values to be 4, 8, and 6 as double precision floating point numbers. So all of that, I can do that in one concise statement, and it's very convenient. And then if I want to go ahead and read something from that data set, again, SQL style, I can just say select from data set and provide the name of that, or the path name of that data set. In this case, there is no where clause or anything else. And similarly, you can do inserts and updates and things like that. So really, by the way, this language, this data manipulation language, this is independent of which specific language bindings you might be using. So you can run this in a shell, and I'll show you that in a moment, sort of in this command line interface. But then let's say you are running this in the context of a Fortran program, or in the context of a .NET C# application, for example. The queries are exactly the same. So these language bindings for these specific host languages are all the same, in the sense that you have a way of, in database speak, establishing a connection, read as opening an HDF5 file type thing. But then once you have a handle established, a connection established, so to speak, with that HDF5 file, you can just fire away with these queries, and it doesn't matter whether your host language is Java or of course, there are some nuances here. Let's say if I want to pass from this HDFql, let's say I'm reading a data set, but now I would like to pass the result of reading that data set in an array to the programming language, to the host programming language. So let's say I'm doing this from Java, and I would like the result of this to be passed or initialize the value of a Java array, then that's possible. And the sort of the facilities, how convenient that is, they vary a little bit from host language to host language. But the queries themselves, they are pretty much identical. It's the same HDFql language, regardless of what your host language is. So taking that, that's all great. But now, thinking about Jupyter Notebooks, graphical user interfaces, I thought, well, let's try to take that convenience to the next level. And that's where I remembered, for those of you who are using an interface like Emacs, an editor like Emacs, although Emacs is a lot more than an editor, you can embed source code in a variety of languages in just text files, and then you can actually execute this code. So what I did here is two things. Number one, number one is I just copied this code. So this is the same HDFql code as in the example. And I sort of embedded it, this is all plain text, into this begin_source and end_source block, if you want to call it that, and you call that markup or markdown, however you want to look at it. And I told this sort of source block identification capability that this is HDFql, and then that I want the results in some form. And so what I can do is I can move my cursor into this environment. You see here the line in which my cursor is sort of highlighted in this orange tinge. And then I can hit, you can't see that, Control-C, and that's sort of the trigger for Emacs to say, oh, somebody wants to execute a source code block, and then depending on the language with which you want to interact, this might be, in this case, it would mean execute that HDFql query. In the case of a C program, it would mean, well, take that source code, compile it, and execute it, and return the results. Or in the case of a Python script, it would just mean fire up a Python interpreter, interpret that snippet of Python code and give me the results. So if I hit Control-C, Control-C, it feeds me back the results, which is in this case, yeah, the output from the second statement, which says, yeah, create me a data set. Actually, I said that wrong. It's the output from the third statement, which is after I created this data set with this initial value, I selected the whole data set, which is very small in this case. And just to show you that I'm not cheating here, is I can have another source code block. And in this case, it's just the invocation of h5dump, show me all the properties, because I want to see that this really enabled compression and all those other goodies. So I can execute a shell, in this case, a bash shell script, the same way I can execute HDFql or something else. And so if I do that, then you see the output down here, and lo and behold, it created this group, and then the data set inside of this group. It's double precision floating point, little endian in this case. It's 3. For the size, we applied compression, and deflate level is 0, and a few other things, and here's my initial value. So that gets the job done. And of course, there are some fine points here, which is the things like syntax highlighting. So I'm not suggesting that I've achieved what's possible here, but you see that the sort of the SQL-like keywords are highlighted in one way of coloration and font. Then sort of what I would call HDF5 related keywords like file and dataset and so forth are highlighted in another way. And then things like type related information like this double here is highlighted in another way. And all of that is actually rather simple. I forgot if I included a snippet of eLisp code in the notes. I did. So all to achieve this requires a little more, but at the core of it is really to basically write a little bit of Emacs Lisp code and then basically have Emacs Lisp on startup load this code. And if you are an Emacs user and you want to get involved, not just with HDFql, but also with better supporting HDF5 and Emacs, I created this GitHub repository here, and I'm going to zoom in here a little bit. So we have plenty of ideas for what to do next, but for now, it's just HDFql. So here you can see this example that I just showed you, and the actual source code is in here. So that eLisp file, this is basically what I had on my slide. But then when it comes to syntax highlighting or font locking, that's the Emacs terminology for this. Here you can see HDF5 keywords and HDF5 type keywords, and then HDFql keywords and so forth. And all of that, of course, leverages what's there in Emacs already in terms of the so-called SQL mode, it would make sense to reinvent the wheel here. So we have already pretty good support for indentation, font locking, and so forth, just out of the box with Emacs and SQL. And so we are really just adding a few bits and pieces that are sort of non-SQL standard and to achieve what we want. And yeah, I would just encourage everybody, if you want to, if you are an Emacs user and you want to make more of this, then you can submit us a pull request. And so other things that I was thinking about, for example, was there is a capability in Emacs called your snippet. So sure, there are things like LSP mode where you can talk to a compiler and then have that deal with auto completion and things like that, and error indication if you have syntax errors in your HDF5 program or your program using applications. But there's also a very simple templating mechanism where you can just, I mean, who remembers how many parameters in which order H5D write has, for example. So with your snippet, you could just have a keyboard shortcut that whenever you type that and type tab, it automatically expands the whole H5D write or H5D read call. And then you can just sort of do the final tuning of to the context. And you can also take that, earlier we spoke about resource management and so forth. What we could use this for would be, for example, to deal with error handling, so that you insert not just H5P set create intermediate, but you would also, okay, since this is not a call that actually acquires a resource, there's not so much of a leakage problem here. But let's say we do an H5G create, you also want to definitely pair this just to make the user aware of that it's your responsibility to ultimately release the resources associated with that group. So it would be easy to write a snippet, a snippet template that matches the user can still choose to delete this, because they might say, well, I'm passing this group back, that handle, that group handle, as the return value of that function, and that's perfectly fine. But nevertheless, I think, yeah, we should try to encourage sort of safer coding practices, especially in C or in languages where you have to be very, very deliberate and very explicit about resource management. So that's all I had for today. I'm going to pause here, and in the remaining few minutes, if there are any other questions, observations, contributions, feel free to unmute yourself and chime in.
Yes, Gerd, I have a question.
Sure.
I'm looking at the select statement that you have the cursor on right now, the select from dataset.
Yeah.
When you're, what's going on under the hood there when you execute that from Emacs Lisp? Is what are you getting back from H5QL, and where does, in other words, when I look at the results and I see the doubles there, is that text that H5QL is returning, or does it return actual doubles and then Emacs List takes it from there?
Yeah, good question. It's actually just text. So the font here is too small, but this whole thing is based, what comes with HDFql is this HDFql CLI, and I don't know, it's probably too small, but yeah. So this command line interface, and here you can type in select, I'm in the wrong directory here, select, but you can type that in here.
Yes.
And all this Emacs org mode block does is basically take that text, it writes to standard out in this case, and I'm just taking that and copying it into this buffer and echoing it here. So yeah, there is no marshalling or type information involved in this at the moment.
Okay. And just out of curiosity, when you control seed and executed the H5QL, what was your intermediate language of choice there? When you were using H5L, QL, but you were generating it in C or Python?
Oh, no. So what HDFql actually does is, what Emacs does is it takes these expressions and passes them to this HDFql CLI, because if I forgot already, is it exit or quit? Yeah, if I just run HDFql -help, you see here, there's help, version, debug, no paths, but there is basically --execute equal, and then I can just have a string that consists of statements like this. So all I'm doing here is really invoke at the moment HDFql CLI with --execute, and then I'm passing this whole text block, so to speak, to HDFql CLI, and that then internally sort of parses these statements, evaluates them, and in the process of evaluating them, it actually calls the C API and does all the, I mean, it has to create, it has to do a lot of work, as we said, just to execute this thing. It has to create a group, it has to create a data set, then it has to create data set creation property lists to enable compressions, set the chunking, and so it has to do a lot of work, but HDFql does do that all internally, ultimately using the C API.
I see. Okay. So the HDFql does generate Python or Java, or it can generate that, but that's not really what's going on here.
Yeah, no, in this case, it doesn't. It really, it has, it basically parses these statements and then has an interpreter. This is really what this is an interpreter that it breaks these, let's say, complex statements down into primitive statements that kind of match one-to-one with C API calls or groups of C API calls, and then it just executes them. But there is no code generation at the, I could be wrong, I should ask Mr. HDFql, but as far as I know, there is no code generation here involved at the moment.
Yeah, but it does allow for HDFql does allow code generation, correct?
It would, yes, absolutely.
Okay.
Yeah, if you, it's an interpreter right now, but then it would look to the outside world exactly the same if you invoked the compiler first and then executed something and then brought it back. The user couldn't tell the difference.
Okay, all right.
Yeah.
All right, thank you, got it.
Okay.
All right.
Great. Unfortunately, that brings us to the end. We are a little over time, but this was really just sort of an appetizer, and I hope, I'd be surprised if I was the only Emacs user in the HDF community. So hopefully some people will come across this and sort of start making contributions, because as I say on the GitHub page, we can also then think about invoking command line tools, meaning h5dump and so forth, from Emacs, and do something useful with the output. And then if you are interested, for example, in HSDS, the RESTful service, there's a REST client for Emacs. So you can talk directly to HSDS from Emacs and do all kinds of interesting things. So it's really, yeah, only your imagination is the limit here. And yeah, we can do lots of interesting things. Okay,
thank you.
Thanks for coming. Happy New Year again. And we'll be back next week. And yeah, thanks for coming. Bye.
Bye.